Oh yeah.
Sadly, it's not that bad. All right, calm it on down. You guys need to be writing your.
We need to make that.
Yes, please. But there's nothing on the graph quite yet.
Oh man.
Okay, next time come to class a little better.
I will.
Okay.
Promise.
Sorry, there you go, guys. Thank you for letting me do that.
Is this the part of 6.3?
Everybody answer.
Yes.
Said it like
Don't
you-
try this
Yes.
way.
Times.
Making sure everybody knew, okay?
Okay.
Okay, okay.
And what?
Yeah.
Yeah.
Maybe.
Yeah.
Yeah.
Wait until. Actually, you know what, Johnny? Karen, can you grab the first aid box?
Oh, sweet.
Why don't you go back on and she has like alcohol in it for you? See the I know. It'll hurt, but it's better.
I put lemon.
Johnny,
Feels
what
like
do you have? Oh. Disgusting. What is it?
It's chocolate
It's
schedule
disgusting.
No. Normal schedule. You guys ready? Here we go.
Jesse said that today.
Disgusting.
It's alright. We're good. We're good. It was his last one with us today. Thanks for this.
He said, "Yeah."
That's both.
Next Friday.
That's
Alright, Robert, we're good on the schedule, yeah? Okay. So, listen. Kiddos. This is the most basic exponential function you can have. However, Josh, quick question. If there's no numbers shown, what would A be?
1.
Yes. So we can think of it as 1 times, it's okay. It's okay. You don't have to stress about a water bottle. Don't let it ruin your algebra grade. There's a 1 in front. Okay? Here's how a normal exponential function looks. And Jordan, this is what you were talking about yesterday, kiddo, right?
Yeah, that's what I mean, because it goes like this. It goes really, it can never hit the zero.
Yeah, it can never hit the 0 on the left.
Oh, I remember
And
that.
on the right, it's growing. That's why when you hear guys, we're okay. You might hear like in novels, or you might hear in someone's speeches online, or if you're listening, I don't know, your parents might listen to the news at night or something. If there's a financial person that comes on and talks about exponential growth, something growing exponentially, pastors sometimes talk about exponential. It means this, it's an exponential function, and they're saying that because it grows super fast. Now, question, if this was a line, where would it be going? If this looks kind of like a line, then where would it be going?
The zero.
Yeah, it just keep going, rise over run, rise over run, rise over run. It has exactly 1 slope, right?
Yeah.
Now, question, how many slopes? Guys, come on. A line has exactly 1 slope. It's okay. Focus on it. A line has exactly 1 slope. It would just keep doing what it's doing and keep going, right? However, exponential growth says, nah, I'm going to go faster and faster and faster and faster and faster and faster and faster. Right?
Yeah, sometimes.
So question, if you were trying to do like a, I don't know, say you're snowboarding, okay? And let's say you're trying to do like a jump. Let's not even do snowboarding, let's do skateboarding, okay? And let's say you're trying to do a jump. If you were to try to do, what are those called where the guys go up and they like touch it with the hand, their feet are up in the air and they come back down?
Oh, ball?
Yeah.
The ball?
Halfway?
That's what I play.
Okay. Would that be very exciting if it was just off of like a line? Yeah, you couldn't do it. You would totally eat it. You would break something. I don't know. At least you'd have to do what Johnny's doing and totally get it out. It'd be rough. Right? You can't do it off of a line. You can't do it off of a single slope. Why? It doesn't get any steeper. But you get a lot more air if you go up something curved like the exponential function. Oh yeah, you get way more, right? So, exponential growth is really, really fast. Now, I need you guys to help me out real quick and think about domain and range. Okay? I need you guys to think about domain and range. It's been a while. Do you remember what kinds of variables domain measures? Is it x's or is it y's? Good. Now, here's a silly way that I used to teach my old algebra class, and let's see if it helps you guys. So I'm going to actually start with the bottom one. So if domain goes with x, range goes with what? I like to call it a rangey. It's a little baby rangy. It's a little rangy. Why? Range? E. Yeah, right?
Oh.
And then I think of domain X. Sounds like a medicine or something. One of those things that would be on one of those pens that you get for free from like a doctor's office. Rangy and domain X. Anyway, silly way of remembering it, but range goes with Y. Domain goes with X's. Now, we know the X-axis is this one, right, guys? The Y-axis is this one? Okay.
Yep.
So question. Domain wants to know how many X's does this line go through? How far left? It does go through 0, but doesn't it go through 1 and 2 and 3 and 4? All those different X's? How about negative 1? Does it have a point? Negative 2, negative 3, negative 4? How many X's are there? Infinitely many. Now, how do you write that? You guys remember?
No, sideways 8.
Good. You can do all real numbers. You can actually type that. Or there is the infinity
Yeah.
symbol. You can use that.
So we have the negative and then we put in the bracket.
Now, I think you guys did use it. You guys learned interval notation where you talk about like beginning and end.
Yeah. But not in this. Yeah.
We could show from negative infinity to the left to negative infinity on the right, but this is actually something I teach my pre-calculus kids, so let's not go that crazy. We'll go ahead and just say it is infinite. It is infinitely left and right, but we're going to say all real numbers.
Doesn't it go negative?
Mighty large.
Yeah, to say going left and going right. Can I just go ahead and, because I'm using my mouse today, can I just do the number sign? Is that cool? Okay. Now, how about range? Those are the y's. Does y equals 0 have a point? No, it's not allowed to be 0. All right, how about y equals 1? Does that have a point somewhere?
Yeah.
Yeah. How about y equals 2? Sure. 3, 4, 5, 6, 7, do they all have points?
Yeah.
How about negative 1?
No.
Okay. So how could I explain or express all of my y values? Greater than, but not equal to, right? We're going to say 0. 0 is the one that's not allowed, but since this has an arrow, it's going to keep on getting closer, 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 closer for forever and never hitting. That's called an asymptote. Asymptote is going to be
1 over.
Don't worry, it's a snazzy name for a line or function can never hit. Okay, let's keep going down.
So we don't put 1?
Control.
No, because
Bases are equal to 1.
greater than 0
You like
allows for 1/2 and 1/3 and 1/4 and see what I mean? Yeah, if we did 1, we get in trouble. Okay,
Is it always going to be like that?
I need you guys, yes, unless it gets shifted. Remember the shifts that we talked about, you guys talked about last semester? That might change things. Alright guys, this is a little bit of an intense page. I need you guys to go ahead and take a little bit of time to get these sketches down. Everything on here is important. Not that you have to necessarily memorize, but I need you to get this down in your notes for you to be able to use in homework, okay? Do I need to have you guys start holding up notes? Well, I think you need to be right. You gotta write these down. You can look on someone in your group and see if you can check it. What? Josh, you need to be writing these facts down, bud. It's super important.
I got you.
Excuse you. It's okay, it's okay. Come on, you guys are writing down graphs. Josh, for tomorrow, I'm gonna have you and Jack switch places. Don't do it now, it's still distracting. But tomorrow, I'm gonna have you and Jack switch places. You see where you start? Josh, you and Jack?
Yeah, I did.
Wait, I'm sorry.
Lending my notes.
Okay, do you guys see the swoops though? I mean, they're different directions and they're going different ways, but they're all exponential. Just
It's confusing.
the signs are a little different for A or B, and it changes which way the swoop is going. Swoop, there it is. Anyway, keep writing, keep writing, keep writing. Gotta get the other graph too.
Oh.
Because they show different things, right?
Yes, it is.
But remember, it's an exponential swoop, right? Not just any swoop. Do you see what's changing with the A on the top graph and with the A on the bottom graph?
Great.
Nope.
Remember, greater than 0, what does that mean? Like, what's the short, quick way of saying greater than 0?
One or more.
What about 1/2? Or 0.1?
Yeah, that's more than one, right?
Nah, 0.1 is less than 1.
No,
Would you rather have a whole pizza, 1, or a tenth of a pizza?
More than.
Depends on your diet, right?
Like,
Yeah, more than 0. So I say positive numbers, so that helps. A is positive, and if A is less than 0, A is negative. Any positive is greater than 0, any negative is less than 0. Same thing here. A is positive, A is negative. Now, hold on, wait, but these swoops go differently, right?
yes, they do.
So, both of them have positive A's and negative A's. Question, what's different?
Oh. B is greater than 0?
You guys see? One has B being greater than 1. And one has B being between 0 and 1. Now, some of you guys actually, in a couple things you've said today, it's easy to forget there are numbers between 0 and 1, but aren't there a lot of numbers?
Yeah.
Infinitely many, yeah. Give me examples of ones. I've already said some. What are some
Point
other
five.
ones?
1, 2, 3, 9,
0.5,
0,
0.1, 0.32, blah, blah,
Wait,
blah, blah.
how big of a difference does it make if there's a 0 and a 1?
I was there.
If there's a what?
If there's a 0 and a 1 and a B and a 1.
Oh, 0 and 1. Those are all the numbers, Robert, we were just saying, like 0.1, 0.5, 2/3, 5, 6. Anything that's less than a whole quantity at less than 1.
Does the 0 mean?
No, remember, B isn't allowed to be 0. So these are the only numbers B is allowed to be.
Okay.
Now, wait. B is the base, right? You guys remember?
Yes.
So if the base is something bigger than 1, then it's growing. Because we always read graphs from left to right, kind of like you read a book. Well, in English. In Hebrew, it would be a little different, right? But coming back up, in English, we read left to right, so we're saying that this is increasing or going up. So when B is greater than 1, when B is 2 or 10 or 100, we're growing. Now, down here, if you guys were on this one on a skateboard, what are you doing? Going up? Oh, you're going down, right? Not necessarily in a bad way, but going down. So when B is a little number, in between 0 and 1, we're going down. When B is a big number, we're going up. When A is a positive, it's going to be on the top part of the graph. When A is negative, do you guys remember last semester the reflection?
Yes.
Or the flips? When A is negative, Jordan, I see you. Hold on. When A is negative, oh, come back. When A is negative, it's just going to be flipped down. And then when A is negative for this one, it's flipped down. Does that make sense? Okay, we're going to get some examples. Let's go ahead and, actually, let's do examples right now. Okay. I want you guys to go ahead and just write, you don't have to write all the words, just say graph, okay? In your notes, just put graph. And what we're going to graph, number 1, now remember, we're practicing it like homework. Write the problem. F of x equals just the problem, not the words, Aiden. It's okay. It's alright, Jay, we got it.
What? Oh my gosh.
Hey, Aiden and Josh, you better write the word graph, and you're writing down number 1.
Write the word graph?
Well, I'm not thinking you write all the directions, just write the graph, like GRAPH for your directions. Does that make sense?
Do you have to draw the graph?
You have to write that whole thing down.
Nope, just the word graph.
Oh, so we don't have to write the equations?
Did you guys do them last semester? I don't remember if you did.
Do what?
Yeah,
No.
like boiling and stuff.
Oh, we're learning that in bio.
Those are so important. Guys, it's crazy how much, now listen, hold on, wait. You guys are ready. Getting ready for us to do the example. It's crazy. I just want to let you guys know something. It's crazy how much I have used what you guys are learning to remind my pre-calculus and calculus kids the last week of what they should already know. Now, they're doing crazy hard math. Like, it's intense. It's a few years away. Like, you guys would see one of their problems and say, huh, I have no clue what the words even mean. Now, even though you wouldn't be able to even read the directions, I've been telling them stuff like, hey, if you have 2 same bases, remember you have to add. Now, they're kind of going backwards with that, but I still have to remind them of that. And I'm like, thank an algebra teacher if you can do this. They've been having to do crazy things like exponential functions and having to think about how they grow, and I'm like, domain and range and tables. I'm saying think an algebra teacher, because that's where you first learned it. Maybe some of you have seen this in pre-algebra. But guys, each of these things is important because it helps you later on with the math that you're going to see, okay? Now here we go. we need to graph the function. How many of you guys have the graph like pictured in your head right now? You're ready, you're 100% sure that's going to be an A if it was a quiz. Not many, right? So hold on. How do we normally do graphs? Do they just like pop into our head, or do we have to kind of build them? Okay, so hold on. Let's work together to build them. The easiest way to start by building, what am I making? What am I making? It's okay, keep checking. Call it out. Oh, it's really not on there?
Oh, graph. I mean, a table.
Yeah, where is he? He's not up there?
You're thinking.
Sorry, I'm making a table. He's not up there. Let me get him up there. Poor guys, you're like, you're not making anything. This is lame. Okay, hold on.
I know exactly what's all you about.
How about,
I was working.
I know guys, thank you for your patience. Whew, there it is. All right. You guys see my table? Get my table out. Alright. We like to start making graphs when we don't really know what they look like by making a table. Let me zoom in on this example, okay? Alright. We're just looking at number 1. We want to graph some stuff. Now, when you guys look at the graphs you just did, what kind of x's do you think we should plug in? Should we start at 0? Is that where the graph starts? Or should we start negative? Okay, let's start negative. Now, we want to keep the numbers kind of small because you guys notice where we're plugging it into, right? Let's just kind of build them as we go. Is that okay? Let's start at -2. This is usually a good place to start. -1, 0. Yeah, that's what I was thinking.
That's like.
It's kind of a good place to start. It doesn't always work out perfectly, but that's usually where I start. -2, -1, 0, 1. Yeah, f of x is like the y value, like y equals. Yeah. Now, kiddos, we actually haven't done one type of example that's like your homework, but hold on, I think you can do it. My question is, how do we evaluate the function value when x is -2? How do we find what to fill in here? Jordan.
You plug it in for the exponent.
Yeah, plug it into the variable spot, right?
Yeah.
Okay, so we could, now maybe we might need to show some work off to the side. For instance, I'm going to go ahead and do when x equals -2. We're going to have -2 times 4 to the -2. Now, hold on. Stink, we need to figure out a number for this. Okay, hold on. PEMDAS tells us to do what first? Do we do this multiplication first or this exponent first? Good. So, exponent. Wait, how do we do 4 to the -2? We're not doing this yet.
1 over 2, right?
It's 1 over, because 4 is in the wrong spot. Remember, he's over 1. Where is 4 squared going to go?
1 over 4 squared. Which is 116.
Alan, check it out. Remember, when we have a number raised to a negative exponent like this 4, the negative says, no, put it down.
You always have to put it down.
Yeah, unless it's on the bottom, then we flip it up. Okay. Who is 4 squared, guys? Who's 4 squared?
4 squared is 16.
16. So we have -2 over 16. If you don't know how I did that, remember, -2 is over 1. Yeah, -1/8. Now, how do we put that on a graph? It's going to be really small, like down here somewhere, right? Oh, just put 2 points.
It can never be zero.
Do you guys see my little baby point?
Well, wouldn't it be on the negative side though?
Ooh, it is on the negative side. Do you see it?
What?
Oops, now I just ended it.
Oh, right, yeah. Yeah, it is.
Oh, it's -1. I thought it was going to be at the bottom.
Oh, wait. What did I graph? -2? Positive. Yeah, you're right, Jay. Where should this go, guys?
Oh, that was correct.
Snap. I was too focused on getting my pen ready. Do you guys see my -2? He's kind of small. He's right down here. I'm trying to make him obvious.
Where? Oh, on the graph?
Yeah, on the graph. I'm trying to make him bigger. Do you see him?
Yes.
Now, hold on. We need to plug in -1. Oh, I struggle. We got to keep plugging in. Okay, that's all right. -2 times -1. Wait, where does the number get plugged in? Check your function. Where does -1 get plugged in? The x. Good. 4 to the -1. Does that make sense? Now, what are we going to do with 4 to the negative? 1 over. And 4 to the 1 is 4. Now, what's negative 2 times 1/4? Negative 1/2. So let's plug that in our table, yeah? So negative 1, we're going to go negative 1/2. That's down just a little bit more than our other one, right? Okay, can I keep plugging?
Yes.
So I'm going to have my 0, so negative 2 times, wait, guys, how do we do anything to the 0 power? Good. Not 0, careful. It becomes 1. Negative 2 times 1 is negative 2. Is this making sense? But that's going to be a lot further down, right? You guys see my point? You answered my question on that one, but that was good. Now let's plug in 1. Now, hold on, kiddos. How many of you can plug this in your head? Some, but not many. This would be some work that you might need to show on your paper, yeah? And if you guys are doing your work on like a whiteboard or you're doing your work on another piece of paper, you need to turn that in with your homework or else I don't know. And I wouldn't know your homework if you're doing your work on another piece of paper from someone who just cheated and stole half the answers from the back of the book, right? So show me that you're working. Okay, what do I do with 4 to the 1?
It's just 4.
Oh, it's just 4. So what's negative 2 times 4? Got it. You know what? I'm not even sure if we need to go any further. Kiddos, if we have 1 negative 8, isn't that way down here somewhere?
Yep. Sure.
Can we connect this with a swoop? Yeah, we can. Oh, that's crazy. I didn't know that. Now, kiddos, we're not going to do another example because I think that one kind of took a long time. But question, how did we get this graph? How did we get it? We started by making a table. And then we had to do the work piece by piece to get point by point until we could see the swoop. Now wait, what made this swoop go down? Help me out. What made the swoop go down? Jordan? Because 2 was negative. So this is an example where A was less than 0. Does that make sense?
Yeah.
Okay. Now hold on, we're not quite done, but we're close. You guys have your swoop? Okay. We have one more page. We only have a couple minutes, so I'm not going to make you guys write all the things up above. So just take a second. Look, I'm going to put little parentheses. I just want you guys to listen, okay?
No
Do you remember? No writing. Just listen on this one. Hold on, you got to listen though, or else we got to stay later. Okay. Do you remember last semester when you guys talked about shifting?
No.
When graphs shifted to the right or to the left? Okay. With shifting, this little example, this little equation up at the top says, hey, exponential functions can shift also. And I just want to do quick reminders, so I want you guys just to answer, and I'm going to fill in, and then we'll make sure they're right. If we have x minus h up here in the exponent, it's next to the x. Do you guys remember whether we shift to the right or to the left if there's a minus up there? You would think left because there's a minus, but on the inside, by the axis, it's actually backwards of what you think. So you're actually going to shift exactly to the right h units. Now, what do you think is going to be the answer to how or what you're going to do if you have x plus h? You're going to shift left h units. Now, we're almost there. 2 more things. Question. What if k, wait, that's an addition on the outside. If we're not going right, left, what direction do you think we're going?
Left, right.
No.
Up, down.
We're going totally different. We're going up, down.
Are we really?
Yeah.
Yes.
If k is greater than 0, what do you think we're doing? Up or down? Good. We're going to shift up k units. And then what if k is negative? What are we doing? Shifting. Okay, wait, pause. You guys have done a great job. Oh, I didn't write down. This is technically a review from last semester, but I wanted to let you know that when you are graphing maybe with your tables, or I should say with your tables, you might have some that are a little crazy with widows. I need you just to remember PEMDAS. I need you to remember PEMDAS. You're going to be plugging into X and getting a graph. So work through homework carefully. Now hold on, wait. What is homework? If you want to, get your phones out. You take a picture in the back or up here. Oh my goodness! Wait, stay. It's going to be awful. Okay, some of these questions are matching questions. Oh, those are kind of quick. Some of them are like just plug in and then you're done. One number. Those are kind of fast. A few of them are graphs. Do the best you can. Show your work on graphs especially and plugging in. Got it?
Yeah.
All right, this is due tomorrow. Take a picture on your way out. Take a picture on the way out. I will not be here after school. If you need me, I'm here lunch. Take a picture. Do tomorrow.
Today's a big lesson. Actually, all of you guys are here. If you want to grab me that big file.
Wow.
A defines your homework to be able to get out number right now. Oh, you should see. It'll be up there, David. Johnny, go ahead.
I missed most of the homework from the beginning of the year. I wanted to get but the 5.5 worksheet, I don't have that.
Oh, that's not gonna work then, huh?
Yeah.
I have a copy of it. Right back there somewhere. Yeah, I think it's in that pile here. It's an algebra worksheet. And it says 5.5 on it. That would make sense when you lost points. Did you find, where's that big, stuff? Do you think you can do it?
你等会吧。
但是我不用提前等我。
好吧。
我等了你俩。
With a 5 raise, come here. And I'll have to work for it. Thanks,
Yeah,
John.
thank you.
But the rest of them, just make sure you give it to me and we'll get those makeup.
Okay.
Miss D said, "What the crud?" Ah!
You said that?
She said it yesterday after school, and George and I just kept yelling.
We should say what you were saying. That made me say what the crud.
What did you say?
I
No,
said I
no
love drugs.
Or the other stuff. We don't say never know.
I love drugs. I love all types of drugs.
Yeah.
And you should never become a drug dealer so you can't sample your own product.
Go ahead.
Oh.
But I love drugs.
Oh. Did you find it?
Yeah.
Sorry, I didn't know which one it was.
Where is he?
Yeah. Just once you put it in the cart, and that way it will belong. Sorry, I heard
that was my bag.
Okay. Give me 1 second.
Yeah.
There. I talked to Mrs. Katz. Long story short, stop the recording.